Routing in wireless mesh networks is very similar to the mapping software. The task is to find the best route from point A to point B. Unfortunately, we cannot use gigabytes of memory like on smartphones. Routing must be realized in a low-cost hardware with a million times lower resources on IoT devices. Moreover, routing should be realized in real time. Therefore, routing is a real technical challenge, especially for extensive networks. That's because the number of possible connections between devices increases quadratically with the number of routers. More than 32,000 possible connections can be found in wireless mesh network with 255 devices. Routing is then selecting available connections to create a route between points A and B. Mathematics quantifies the number of available routes as a huge combination number. For 255 nodes in the network, it's a number with 502 zeros. To solve this technical challenge, there were invented dozens of routing protocols trying to optimize delivery and define the best route. Let's see one of them, source routing. It's based on the fact that the sender knows the path and instructs routers on the way how to route by adding routing information to the message. It perfectly works in an ideal world. But we are living in a real world, which is not ideal. The partial connections can disappear because of the changing RF conditions or mostly because of the signal interferences. Let's see how source routing can behave in the real world. The routing fails on the second hop, so the routing vector must be redefined. In this case, optional routing vector 54 was selected. And again, due to the broken topology, the routing fails on the second hop, so another routing vector must be used. The routing vector 52 was selected in this case. Finally, the message will be delivered. However, as we could see, it's not a deterministic process. The timing efficiency was utterly destroyed because of the need for partial acknowledgements, consequent delays, and retransmissions. The IQMesh protocol uses different routing algorithms based on TDMA, directional flooding, and virtual routing numbers. Let's see how it works. The message is reliably spread over the network through the collision-free retransmission and finally is delivered. The IQMesh protocol delivers reliability also to networks operating in a harsh and challenging environment. On the slide you see the same network, but with reasonably destroyed topology and connections. Let's see how the IQMesh protocol works in the broken topology. It works exactly in the same way and with the equal timing. The IQMesh protocol ensures self-healing and routing reliability by its definition. Another problem of source routing and table-driven routing algorithms is storing data in frames or tables on routing devices. The problem is growing with the network size and it's often solved by limiting a number of routers or routing hops in real applications. Nevertheless, it kills the basic benefit of wireless mesh networks, extensive routing. The IQ mesh protocol needs only a virtual routing number, it's 1 byte, to be stored on routing devices, and 5 bytes to be added to the routing frames. It's independent on the size of the network. Thanks to that, the IQ mesh protocol can reliably support 255 routing hops. At RFIC specifications, you can find parameter called bit error rate. It's a metric characterizing the probability of failing reception under certain conditions. It's crucial to note that fixed routing algorithms, when implemented without error corrections, can significantly increase the probability of bit errors. This, in turn, can lead to a substantial reduction in routing reliability, underscoring the urgent need to address these potential issues. It's often solved by a limited number of hops in real implementations. Contrary to the fixed routing algorithms, the IQMesh protocol processes frames simultaneously. Simultaneous processing generates redundancy, leading to increased robustness and reliability with the number of increasing hops. Thank you for watching. For more information, please visit the IQRF.org website.